Hi, Joe Cerrone.
And I'm Al Rosa, and welcome to CAD-117-050 Zoom classroom meeting today. We are going to go over to Chapter 5. We have thank you, Joe. We have a question and answer before we did this. We're on Chapter 5, and we have Chapter 5A, Lab 5A, and 5B. If we go down, you'll see there's videos and PDFs all the way through there. We have a picture of Lab 5A and 5B. We have videos for each one. So if you click on 5A for a minute, Joe, quick video.
Got it.
Tutorial. If you left click on it, it tells you the do's and don'ts and how and what's where's of 5A.
5A is an ordinal dimensioning assignment, as Chapter 5 goes through how to dimension mechanical parts.
And 5B. And that gives us a two-dimensional front, top, side view if needed be. This one needs a top and front view. And you have a full solid that is sliced in half, and you will see both halves in there.
Right, and as we look at this video, I believe the two-dimensional is required, but the three-dimensional is bonus. And so it just shows you how to do the two-dimensional part. And I believe there's another video, we'll double check, that'll show you how to model the three-dimensional components.
Okay. That could be too helpful. And then we have a PowerPoint, Chapter 5, Part 1.
And as I said, the objectives for Chapter 5 is how to work with dimensioning mechanical drawings. And I think while we have it open, we'll talk a little bit about it. Let's see if we can increase this a little bit. And so as we look at it, we want to look at dimensions and what's important in dimensioning. Size dimensions and location dimensions are important and need to be placed on the drawings. And then we'll look at dimension terminology. In other words, what is a leader? What is a tolerance? We'll look at American Standards of Mechanical Engineers, Standard Y14.5, which goes through these dimensioning standards. We'll look at do's and don'ts of dimensioning mechanical drawings, how to dimension and determine are determined, tolerancing, fitting, another set of standards, the roles of drafters, the dimensioning aspects of AutoCAD as well. And so essentially, as we look at these different drawings, there are all these different mechanical parts, and if properly dimensioned, the combinations of views will fully describe each object or allow you to manufacture it. I don't know how many times I was called down into the shop for something like this where somebody did not know what size to make something. And so the CAD guys would go down to the shop, take a look at it, pull the prints, and then they would go back and update the drawings so that they can then continue to manufacture the parts. As we look at some of the features and how things are placed, it talks a little bit about datums. And as we get more into blueprint reading and things, a datum is a theoretically perfect element. It's a point at which we will measure other objects from. And we go through a lot of things in the CAD world for manufacturing. We'll also do the same thing for architectural dimensioning. And so in the next chapter, it goes through how to dimension architectural drawings according to architectural standards. And then just some basics, like a size dimension will show the size of the object. And so you can see that 6.75 by 2.12. a location dimension will locate a feature like this hole, and it's given its size. So that information is critical for manufacturing. And then as we look at the terminology helps us match what we're doing with the dimension styles. So for example, if we look at extension lines, dimension text, and then we look at a drawing. So for example, this drawing, and then we were to look at the dimension style. Now, if we go into the dimension styles, we can go to the annotate tab, and then we hit this little corner arrow, or you can type in DDIM, and you can see these dimension styles. And so as we go through and set up these different dimension styles, we'll go through and use that terminology. So as we look at things like arrowheads, let's start from the beginning. Lines, the way the dimension styles are set up, and in the third PowerPoint, it shows you how to set up a dimension style for a mechanical part. We have the dimension lines, which are these lines right here. And then we're able to change the color. Your CAD manager typically does this. Al and I have it set up on the standard mechanical title block. The extension lines are the lines like right here. They extend from the part. And then there's these little things like extend beyond. And so that's this little part right here. Symbols and arrows, you can change from arrows to different types of symbols like dots. Arrowhead sizes, center lines versus center marks. A lot of little things in here, and they've done a nice job by updating the picture to show you what everything does. We're able to work with different text fonts and different text styles. We're able to dial in the text height and the way that's placed, whether it's horizontal or aligned, or if it's a standard. And those are going back to the ASME standards for this exercise. And then as far as, this is a bit of a tricky tab, how the text is fit on the drawing, whether the text is between the arrows or outside of the arrows, where the text is placed. Is it placed in the dimension? Is it placed above the dimension? There's a number of different things that we can do with our text placement. And then this is probably the most important area. This is your dim scale. And if you change this, then the text will get bigger or smaller so that it's readable. And there's a couple of different ways to set that according to the dimension scale. And then lastly, this primary units. Are you dimensioning in decimal units, or are you going to use fractions? Or are you going to use architectural units? So as you can see, there's a few different areas that we can go through and set up. Alternate units will allow you to set this up for a metric as well as an imperial drawing. So oftentimes we would send prints overseas to companies in Brazil, and they were on the metric system, so we dual dimension everything. And then tolerances. How close to perfect does that part need to be? And so there's a number of different areas, but most of it is set up for you in these examples. And I just wanted to talk about that as we looked at our PowerPoint. And then things like guidelines, kind of the do's and don'ts of dimensioning. Place dimensions on the profile view of the feature. Okay, what's the profile view? Well, ideally you want to place the dimension in the view that best describes what you're dimensioning to. And so you can see this is nice and neat. On the right is good, on the left is poor. Avoid dimensioning on the part. And it's avoid, you don't have to do it. Sometimes you have to put things in places. Avoid crossing dimensions so that you can kind of have something like this, which is easier to read or neater. And so as we start to work with how dimensioning works, neatness counts. And some of these rules will help you determine the best practices for that. And that's what we often hear. I just don't know what I'm supposed to do with it. Well, follow this standard and we'll tell you. And so they put together these dimensioning standards. They tell you what size the text height should be. They tell you how far the placement from the object it should be. They tell you how far dimensions are from each other. Basic things that can be set up in dimension styles. They're rules that are meant to be broken in some aspects, provided that you have the dimensions to fully describe the part. That's the most important thing, is to be able to manufacture it. So more standards, text height, it's about an 1/8, 0.12. We typically set those up at 0.125. And then different types of ways of dimensioning different features. And so that's what this exercise goes through and shows you how to do as we start to look at things like how to dimension angles, being able to dimension in degrees, minutes, and seconds for very precise dimensioning symmetrical objects by putting in these symbols that show symmetry. And then ordinal dimensioning, which is our first exercise. And then ordinal dimensioning is very popular in manufacturing because they work off of a 0 position. And this makes it so that the machine tool can be set up off of the 0 position. And then it just makes it very easy to program it, because I can program my whole locations as X3, Y3. And then this would be X11.42, Y3. And so an operator who understands how to set up the machine can quickly make this part without doing a lot of calculating. And then other things like being able to show interior features. What is the hole geometry? What is a counterbore versus a countersink? And how are those symbols set up? And so the textbook does a great job of showing the basic mechanical aspects of dimensioning mechanical parts. With that, I think we'll switch over to the CAD assignment. We kind of talked a little bit about these do's and don'ts. So let's switch back. Our mechanical parts are lab 5A. And this drawing, there is a video for, but essentially what we did was we set the part up at program 0, or at the user coordinate system 0 location. So when we look at this part, we can see the UCS axis is right there at the 0 position. And then if I change this to a top view, I'm going to change my background color if I can. We can see that the dimensions, and I think I'm going to do one more thing. I'm going to make the green darker. Not much darker, but dark enough. So as you dimension with ordinal dimensions, you have a program 0, and then as you apply these ordinal dimensions, the first one will be 0. And then if you repeat the dimension ordinate, as I come in and I start to tag these different features like the center line or the endpoint of this arc, you'll notice that it knows exactly where that is vertically to the 0 location. And that's what we want to be able to do. And then we can do the same thing ordinal with our horizontal locations. So it's an excellent assignment for being able to do manufacturing prints. And so we'll draw this. It's not a real difficult part to draw, but we're getting into some of the other aspects, which is how to properly dimension your CAD drawings. So that's lab 4A. You'll put that on the title block. And on some of them, we'll start adding these bonus features like creating a 3D model for that part. 4B.
5.
Thanks. 5B is right here. And 5B is our machine block. And this exercise is also done in model space. And if I go and I grab a plan view or a top view, we can see that. I'm going to try to darken that black up a little bit more, or darken that dimension up a little bit more, try to make it more. That's not the spot. I actually have it white already. I want to darken it on the layer color for dimension. And the reason it's light, I just figured it out, is because it's a locked layer. And so when things are locked, it makes them shaded lighter. And so much better. We have this mechanical part, and it's basically just a metal part with holes in it. And then we go through some of the terminology on how to create these different dimensions. And so here's a 1/4 inch diameter hole that goes all the way through with a counter board depth of 1/2 inch. That is 0.375 deep. And that's what that will look like. And then we have some other features that show things like countersinks, which are angled, and things like holes that are drilled. And then once we have the part drawn and dimensioned, we'll put that onto the title block. And then the 3-dimensional model is bonus, and we'll make sure that there's a video in there for that. But at this time, it's not required to do the 3D. Okay, getting back to the D2L. So the PowerPoints are here. Here's part 1, 2, and 3. Here's lab 5A. And it's just our blueprint. 5B. I think we're going to have to come back to that one, Al.
Yep.
And then here's our title block that we'll use to draw these. And again, we'll draw those in model space. And when we draw those in model space, we'll be able to see them in our viewport. If you double click in the viewport and then do a zoom all, you zoom all.
Or double click the wheel in the center.
Right, which is better. Al's got the best ways to do these things. All right, so switching back to our lecture, that's what's required. You're required to do lab 5A, 5B, save those, and then put them into the assignments folder. If we look at the assignments folder, we can see that module 5 is due October 14th. Last week we went through module 4. Module 4 has a mechanical and an architectural drawing. The guest cottage is right from the textbook. And it goes through how to do the 2D floor plan. And we'll come back to this project in later chapters where we will go through and add the dimensions and add the symbols for electrical and plumbing. And so this exercise, what's required is to do the drawing, the details, add the notes and the doors, and the shading for the walls where the hatch pattern applied. Some bonus content if you'd like to do some extra credit right there. And then the mechanical component, again, taken right from the textbook for this Geneva cam and gear assembly. Just basic CAD construction. Shouldn't be too difficult at this point for both of those parts.
It goes into how to array the objects around it.
Right, and so like we always do, we put a video in. We find that those work really well. So if we click on that, the video will go through how to do these basic drawings. And here's B. How to load line types. The videos are good, and we try to keep them at a reasonable length. YouTube sometimes rejects our videos and we have to make them smaller. So that's something new that we hadn't experienced before. So that's the videos for last week's labs. And those will be due, if we look at lab 4, when is that due? Assignments. And then lab 4 is due next week on October 7th. Module 3 is due tonight, 11:30. And the exercise is to complete this model right here of the 2D component. The 3D component is bonus. And then here's the instructions on how to do that step by step. All right.
Is there anything else, Joe?
Go ahead, Al.
Anything else?
Not in our weekly video brief that I can think of right now.
Great.
All right. Is there anything else that you'd like me to cover, Al, before we end this quick video review?
I know a lot of the students are putting their stuff in a Dropbox, or we call it now assignment box or folder, and they're doing a great job. Hopefully we keep that up so we can grade them and send them back as soon as we can.
That's right. Al does most of the D2L management, and I'll do the lectures. And so you should be getting course feedback and information as far as your drawings. If you're having any difficulty with any of the software or anything else, just hit the email button and Al and I will get back to you. It'll give us a little dot here like we have. And so we'll get to that as soon as we get a chance. All right. So with that, I think I'm going to wrap up this video. Thank you, and we'll see you online next week. We're going to open it up for questions now.